Hi everyone, welcome back. Happy Wednesday. So yesterday y'all took a look at some examples of heat transfer when you learned about conduction, convection, and radiation, the three major types of heat transfer. Today we're going to see what heat transfer actually looks like when we're looking at individual particles or molecules, and in what kind of behaviors do they tend to have when they interact with each other. So everybody, what's our date today? April 1st, 2020. Our topic is heat transfer. Working with the same standard as yesterday, observe and describe that heat flows in predictable ways, moving from warmer objects to cooler ones until they reach the same temperature. And this idea is going to be important. Think about that. So our goal is to be able to describe how and why heat flows the way that it does. Our vocabulary is heat, temperature, average molecular kinetic energy, that's all one, and equilibrium. And we're working to answer this essential question: how can we reliably predict what will take place when we combine two objects with different temperatures? And what do we mean by reliably? You should see the word reliable in there, right? So how can we, maybe another word we can use is accurately. Accurately predict what will take place when we combine two objects with different temperatures. And then we're going to end with some independent practice problems and an exit ticket.
The kinetic molecular theory is the theory that all matter is made up of atoms and molecules that are always moving. These particles hold kinetic energy and move around in random directions. In higher temperatures, the particles have high energy, and in low temperatures, the particles have less energy. The more energy a particle has, the faster it will move. In solids such as ice, the particles hardly move at all and hold a regular pattern because the energy is low and the particles are tightly packed. In liquids such as water, the particles have more energy and the freedom to move around. Liquids have the ability to flow and fill the shape of any container they are put in. In gases like steam, the particles have the most energy. These particles are sparse and move around freely. Gases are usually invisible to the eye, and they can be expanded and compressed in different pressures. All matter is composed of atoms and molecules that are always moving. The higher the temperature, the more energy these particles have, and that is the kinetic molecular theory.
Okay, so what I hope you learned from the video is that particles carry a certain amount of energy, right, based on their temperature. So this is the idea of average molecular kinetic energy. We can break this down into words that we are familiar with because it's kind of a mouthful. So what word do you see in molecular? Molecule. Kinetic is related to what? Motion. And energy, right? So this can be thought of as heat. We can relate it to heat. So in our hotter objects, the molecules are moving very quickly and have a lot of energy, as we saw in the video. Whereas in our cooler objects, like ice, molecules are moving very slowly and have much less energy. So we can see here in the solid form, all of the particles, even though it's not that they will never not have energy, right? They're going to just be moving very slowly, but they're still going to vibrate even when in place. Whereas at higher temperatures, when it becomes a liquid or a gas, those particles they have less intermolecular forces, so they're not going to be as attracted to each other, right? They have lower force of attraction. So they're able to move around a lot more and go in all different directions. So when we think about joining substances with different temperatures, think about how their molecules are going to collide until eventually they're moving at the same speed. And this is in a concept that we're going to talk about a little bit more in a second, called equilibrium. So when we're thinking about how different particles, different substances carry different amounts of heat, what happens when we put them together, right? We still have this heat that is able to move from one place to another, whether it's radiation, whether it's conduction, whether it's convection. Heat is always going to travel from the area that has the higher temperature to the area that has the lower temperature, but never the other way around. It's never going to go from lower temperature to high temperature, right? That's just the rule of nature. It's going to move from hot to cold, the warmer object to the cooler object. So you often think about when you put ice in your soda, for example, right? It's not that the ice is making the soda colder. Your soda is actually making the ice warmer, causing that to melt, and then the temperatures of the two are going to reach what we call an equilibrium. Let's look at what that means now. All right, y'all, so we're going to watch a quick demo, and as you are watching, you're going to be filling out your POE table. So you're going to predict what you think is going to happen, observe why it's happening, or observe what is happening, and explain why it's happening. So let's get started.
Fun time of the week again, where I'm joined by Dr. V from Oceanet. Good morning, and it looks like I might have to roll up my sleeves today. What do we have going on here with the different water?
It's an interesting experiment to show our sensing capabilities.
Right, your senses, very important.
And senses are relative.
Okay.
Right? So we'll explain later, but let's go through the experiment first.
Okay.
So I have here warm water.
This is warm water.
This is regular tap water.
Tap water right here.
And this is water with some ice in it,
So
which
cold.
is really cold.
Gotcha.
So what I really want you to do, put your left hand here, put the right hand on the cold water.
Okay.
So one on the warm water, one on the cold
Literally,
water.
just put it on like that.
Just put it on like that. So just feel it a little bit more.
Okay.
So you feel, now you know that this is cold and this is cold.
And I have to say, it's a very unique sensation where you have kind of really cold water on this side and warm water on that side.
As the next step, what I really want you to do, I want you to put your both hands together into the tap water.
Into the tap water in the middle.
Okay, so there's your experiment. Go ahead and pause the video and predict what do you think he is going to feel when he puts both of those hands into the warm water. So he's putting a hand that was in really hot water into warm, and then a hand that was in really cold water into warm. What do you think he's going to feel? And then press play when you have filled out your box for predict.
Okay. And see what happens.
Right now, go ahead and do that.
Yeah, and then tell me which hand feels more warmer.
Wow. Okay.
What do you feel now?
My hand that was in the ice cold water is actually almost not burning, but very warm sensation right now.
Right. So.
but it's almost uncomfortable. In fact, but it's kind of good. And the left hand's actually kind of cooler.
True. So
Okay. So now you have heard what he has felt. So go ahead and fill out your observe chart. Pause the video, and when you're ready, click play.
Basically what happens is that our senses are relative. So the sensing is always relative, it's not absolute. So, for instance, when you walk into a room with really smells,
right,
after some time you get used to the whole smell,
yes,
right?
That makes sense.
So it's more relative. So the measurement is always related to the surrounding.
So
in this case, when you put your hand in the cold water, your hand became really cold, and then when you put in the warm water, the sensing that temperature difference is really high. So you feel it related to your hand, which is really warm.
Now my hand's been here for a while, and actually the pain is kind of diminished a little bit, and it's kind of getting both normal. But it's really amazing that the contrast.
After some time, you stabilize.
Right. Wow. Okay, so it's all relative. Now, when you're dressing out for going out in the warm or cold weather and stuff, so it really makes a difference to bundle up certain parts.
It makes a big difference.
Well, again, a very cool experiment that you can do at home with very simple. And I have to say, when you have one hand in warm and one hand in cold, it's shocking the amount of difference in when you put it back in the middle there. Wow, very cool.
It's a big difference.
Very, very big difference. Always good to dress warm during this winter season, even if we're living in Hawaii. Again, thank you for watching us here on Hawaii.
Okay, and lastly, go ahead and fill out your explain column. How do you think you can explain why he felt the way he felt And over time, what did you notice actually happened? So what y'all actually just saw in the last video is this idea of equilibrium. Equilibrium. And if you notice in this word, what do you see? Kind of looks like we see the word equal, right? So that's going to have a play in this. So this is when two objects with different temperatures mix together, and the idea that eventually they're going to reach the same temperature throughout. So we can kind of see what's that happening here. So if we have block A is higher temperature or hotter than block B, if we combine both, we put both of them together, right? Heat is going to flow which direction? Always hot to cold, until both of those blocks are around the same temperature. And you can further see it in this example here. If we have one bowl of 0 degrees or frozen substance, and then we have another substance that's at 100 degrees Celsius, when we mix them together, they are going to come to the halfway point. And the halfway point between 0 and 100 is 50 degrees Celsius. So we would say that this substance, both of them together, are at equilibrium. All right, y'all, that is it for today's lesson. Go ahead and go back to today's mission document and scroll down to page 3 to complete your independent practice problems related to heat transfer. Once you've worked through those practice problems, take some time to go back to the assignments tab under Teams and complete the 3-question exit ticket on heat transfer. Good luck. Reach out if you have any questions, have any doubts, and I will see y'all later.